Hello everyone, this is Mr. M from Algebra Lessons. In this video, I am explaining rank of a matrix. Rank of a matrix is a very good tool while we are discussing the concept of matrices. To go further, we need to know the basic definition of these two items here, the submatrix and minus of a matrix. While you did your matrix basic lessons, you already covered this minus of a matrix in the determinant part, or finding cofactor matrix. You already discussed that. What is a submatrix? That is the first question that we can share. Okay, submatrix means if I have an m by n matrix, say for example I have a matrix A is equal to 1 2 3 4 5 6. So the order is, number of rows is 2, number of columns is 3, so 2 by 3 is the order of this matrix A. So if we have a matrix of order m by n, then a matrix obtained by deleting some rows and columns from A is called the submatrix of A. Say for example, I'm going to write submatrix of A just like I'm actually going to delete the first column. So this is 2 3 5 6. Okay, 2 3 and 5 6. So that is one submatrix. I can write another one. Just like 1 2 4 5. This is another submatrix. Okay, this is another submatrix. Okay, this is the way we can write the submatrix of a parent matrix. And as you know, the minus of a matrix, that means when we are trying to figure out the determinant of a matrix, we will usually hide some rows and columns. Say for example, I have a matrix A is equal to matrix 1 2 3 4 5 6 7 8 9. If I'm going to find the determinant of A will be like this. I'm going to use the first row for calculating the determinant. So when I'm using the first row, I will use all three elements of the first row. So consider the first element. So when I'm considering the first element of the first row, first column, then you have to hide the first column and the first row. The remaining part, the remaining section is a small matrix, a square matrix. So here this is 5 6 and 8 9. So this is 1 times minor 5 6 8 9 minus second term 2 times. Then what is a minor? You have to hide this row, this column and the same row. So the remaining is 4 6 7 9, and plus when you are considering this 3 times, you have to hide the corresponding column and the row. So this row and this column you have to hide. The remaining is 4 5 and 7 8. This is what is called the submatrix and minus of a matrix means. So here what we are discussing is what you mean by the rank of a matrix. The rank of a matrix, that is an interesting question. What will be the rank? Do we have any connection with the submatrix? Yes, we have a connection with the submatrix. The rank of a matrix is the order of the largest square submatrix. So largest square submatrix. Okay, the order of the largest square submatrix is the rank. Okay, is the order of the largest square submatrix, and there is a condition. its determinant its determinant should not be 0. So when we are considering a submatrix, and if we are finding the determinant value of that submatrix, if it is not equal to 0, then the order of that submatrix is the rank of the given matrix. Let me explain this concept with some examples. Say for example, if I need to find the rank of the matrix, A is equal to matrix 1 2 3. I'm usually always starting all matrices with 1 2 3. It's it's very easy. So 2 3 4 and 0 2 2. Okay, if we have a matrix of this kind, how can we find the rank? That is the question. We are actually not discussing what is submatrix or something like blah blah blah. Not that stuff. We are discussing how to find the rank of this matrix. That is a topic that we are considering. Okay, so the determinant of the largest square submatrix. Okay, this matrix itself is a square matrix. We can check what is the determinant value of this matrix. So go ahead and find the determinant of the given matrix. Okay, so that is 1 times, so you have to hide this column, this row, so that is 6 minus 8 minus 2 times 4 minus 0 plus 3 times 4 2 yep 3 times 4 minus 0 again. Yep, so this is 1 times 6 minus 8 is negative 2, minus 4 times 2 is minus 8, and plus 12. So this answer is plus 2. So this is not equal to 0. So a matrix itself is a submatrix. So we can say that here the determinant of the largest square submatrix is not equal to 0, and therefore the rank of the given matrix A is the order of this matrix. What is the order of this matrix? Order of this matrix is, this is a 3 by 3 matrix, so the order of this matrix is 3, and therefore the rank of this matrix is equal to 3. Okay, so this is the way, this is the one way, the first way, the easiest way you can find the rank of a matrix. Okay, then we can ask another question. If the very first square matrix is not equal to 0, we can say that that's a rank. But if it is 0, what we will do? Okay, then for that also I have one example. Okay, let me use this example. A is equal to matrix 1 1 2 3 1 2 3 2 3 4 2 3 4 and 3 5 7. Okay, so you have to find the determinant of A because this is a square matrix itself. So 1 times 21 minus 20 minus 2 times 14 minus 12 plus 3 times 10 minus 9. Okay, I believe you know that how I did this, and this is 21 minus 20 is 1, so 1 minus 2 times 14 minus 2 is 2, 2 times 2 is 4. Okay, plus 3 times 10 minus 9 is 1, 1 times 3 is 3, so 4 minus 4 is 0. This is 0. That means we need to dig down. Okay, so here the largest square matrix determinant is 0. That means we can say that this point itself, we can say that the rank of this matrix the rank of this matrix will be less than this number 3, because the order of this matrix is 3. So the rank of this matrix is less than 3. Then we can check, we can try to figure out by eliminating some columns and rows from the given matrix and find a square matrix. Okay, if I'm finding a square matrix by eliminating this column, okay, this column, because we need a square matrix, that means we need to eliminate some row also. So that means I'm actually going to eliminate this row also. Just trial and error. Okay, you can try in another way. You can try to eliminate the first column and the first row, then you will get a square matrix here. So I'm actually starting the operation here. If you have at least one square matrix, okay, from this minors, the order of that minor matrix will be the rank of this big matrix, the parent matrix. We can check what is the determinant of this minor matrix. Okay, so this is 1 times 3, 1 times 3, 3 minus 2 times 2 is 4. So 3 minus 4 is equal to -1. This is not equal to 0. That is interesting. So we can say that the rank of this matrix A, is 2, because the minor of this matrix, the order of the minor matrix is 2, and the determinant of that minor matrix is not equal to 0, so that the rank of the given matrix A is the order of the minor matrix. Okay, that is the way you have to find the rank of matrix. So that is actually one way of finding the rank of a matrix. We have another solid method to find the rank of a matrix using elementary transformation. Let me explain one problem with problem of that kind. Okay, so A is equal to matrix 1 minus 1 3 6 1 3 -3 -4 5 3 3 11. Okay, what we need to find is the rank of this matrix. Okay, here in this problem, or all the problems of the matrix, all the problems of finding the rank of a matrix, we can use this method. This is kind of a very solid and effective method to find the rank of a matrix. So basically what we are trying to do is we are trying to make the main diagonal elements as 1s and remaining elements as 0s, and with after a set of elementary row or column operations, which minor matrix with its determinant not equal to 0 is popping up, means that is the order of that minor matrix will be the rank of this matrix. Okay, so what you mean by elementary operations? Elementary operations means interchanging the rows and columns. You can multiply the column with a scalar and interchange it. Okay, so those kind of operations we can do. So our objective is to find the main diagonals are units. So because this is kind of this is not a square matrix, this is kind of a 3×4 matrix. That means when we are taking the main diagonal, we will get only these 3. This will actually kind of an external item looking like that. We can try to check it. Okay, go ahead. Okay, you can use your own way of thinking, but what I am doing here is I'm going to rewrite column 2 as the sum of column 2 and column 1. Okay, and column 3 column 3 as the way like this, column 3 minus 3 times column 1. Okay, what is the idea behind writing this operation? Our objective is to make the main diagonals are units and remaining elements are zeros. You can do whatever operation you would like to do, but you have to write here. So column 4 I'm going to write column 4 minus 6 times column 1. Okay, so what will happen? So just after this elementary row operation, this matrix is going to be like this: 1 0 0 0. See, first these three elements become 0, and 1 positive 4 negative 6 negative 10, and 5 8 8 negative 12 and negative 19. Don't think that I am doing this mentally, because I already did it separately in advance. That is why I am straight away writing the answers. You can practice a lot, and you can do like this. Okay, and I have my objective in my mind. I have to make the main diagonals are units and the remaining terms as zeros. So in the next step, what I'm going to do is I'm going to change the rows. I'm going to do the row operation. So I'm going to change row 2 as row 2 minus row 1, and row 3 as row 3 minus 5 times row 1. Okay, so if you have that objective to make the main diagonals as units, you can easily write what you need to do in these rows and columns. Okay, so then your next matrix will be 1 0 0 0 0 4 negative 6 negative 10. Okay, and 0 8 negative 4 negative 12 and negative 19. So this was the matrix I got after that row operations. Okay. Okay, in this matrix I'm going to apply another column operation. I'm going to change column 2 as 1/4 of column 2. 1/4 of column 2. Okay, so column 2 itself I am changing it. So my next matrix is 1 1 1 0 0 0 and 0 1. See, the main diagonals becomes ones, and negative 6 negative 10 and 0 2 negative 12 and negative 19. Okay, so here again my objective is what? My objective is to make the whole the main diagonal elements become units. Okay, so in this matrix I'm going to perform a row operation. Row 3 will be row 3 minus 2 times row 1. Okay, so then what will happen? So my matrix will be like this. It is a 1 0 0 0. We already done with the first row. We need to work on the second row. Okay, so this will be 0 1 negative 6 negative 10. We worked on row 3, so changes will come on row 3 only. So this will be 0 0 0 and 1. Actually in this point itself we can predict the answer, but now we need to continue a little bit more. At this point I'm going to make some column operation. the column operation is like this. I'm going to change the column 3 as column 3 plus 6 times column 2. Okay, 6 times column 2, and column 4 as column 4 plus 10 times column 2. Interesting. In that operation itself, you can figure out what is happening here. Okay, so after that operation, my matrix is this: 1 0 0 0 0 1 0 0, okay, 0 0 0 1. Okay, so this is the matrix that I found from here. Okay, so now I'm going to interchange. See, because we need the main diagonals as 1. Here we have a unit left over, so we can adjust. If we can adjust this unit here, we can have a 3 by 3 matrix. Okay, in which the determinant is not equal to 0. So we can go ahead and do that interchange. So we are interchanging C3 and C4. Guys, interchanging notation is like this, both way arrow. Okay, so interchanging C3 and C4. So our final matrix is like this: 1 0 0 0 0 1 0 0 0 0 1 0. Okay, so now we have a 3 by 3 matrix. And what is this? This is an identity matrix of order 3. Identity matrix of order 3. And if you can find out the determinant of this 3 by 3 matrix, you can see that this is not equal to 0, and therefore we can say that the order of the parent matrix that is given in the beginning is the rank of the given matrix given in the beginning is equal to 3. So rank of the given matrix is 3. So this is a tedious process. I know that this is a tedious process, but in examination this question will give you a good amount of score. Probably it is 10 or 15 marks. So I hope everyone is enjoyed this video, and if you really wish to get more videos of the same kind, or more videos of the same kind of topics, please don't forget to press the bell icon and click the subscription button. Thank you very much.